Hello everyone. Today we are going to study a method called ANOVA. ANOVA is used to compare several means at the same time. Usually we conduct an experiment where we have several groups and we get the data from the experiment and we compare sample means from those groups at the same time. Suppose a pharmaceutical company developed a new drug, like vaccine for COVID-19, and they want to know whether the new drug is effective, right? So they conduct an experiment, right? Suppose they conduct an experiment where they have three groups of people and each group will be given different dosage of new drug, right? So suppose this group is given 5 milligrams of dosage, and this one is given 10 milligrams of new drug, and the last one is given fake drug, right? This one is called sometimes placebo, right? And then after that, they gather data from each group in terms of the whether they develop the immune system, right? And they want to compare whether there is a difference among these groups, right, in terms of immune system, right? So this kind of situation we use ANOVA, right? When we compare, the sample means among these groups, right? And by the way, these are called treatments, okay? So, in this case, the amount of dosage is called treatments, right? And people who participate in the experiment is called experimental units. Okay, when you create groups, right? The people are selected randomly, right? In that case, it is called a completely randomized experimental design. Let's say 3 experimental units are to be assigned to 5 treatment, right? 3 experimental units means what? We have uh, 3 elements for each group, right? In this case, we have 5 groups, right? So in order to use completely randomized experimental design, you pick 3 experimental units randomly, right, for one treatment. And then you pick another 3 different experimental units for another treatment, right, and so on, right? So let's do an example here. This is about the gasoline mileage, right? So there are 3 types of gasoline, and you want to know whether there is a difference among these 3 types of gasoline in terms of mileage, right? So, you decide to conduct an experiment. In this case, the gasoline types A, B, C are the treatments, right? Now, so what you want to do is, you want to randomly select 5 cars for each treatment, right? Suppose you have 1,000 cars, which have same types of engine size, right? So you randomly select 5 cars from 1,000 cars, and you are going to give gasoline type A to 5 cars, right? And then you select another 5 cars from 995 remaining cars, and these 5 cars are assigned to get gasoline type B, right? And another 5 cars from the 990 remaining cars, and then these 5 cars are assigned to get gasoline type C, right? And then the cars test driven, and you get the mileages, right? So these are the results from the experiment, right? So this is called the treatments, right? We have 3 types of gasoline, and from 5 cars for each type of gasoline, you get the mileages, right? All right. These are called the responses, right? So from this experiment, you want to know whether there exist differences among these 3 groups in terms of the mileage, right? So when you compare, groups in terms of means, you compute the sample means for each group, right? Like this. And also you need to compute the sample standard deviation from that data for each group. And you set up hypothesis like this, right? So for the null hypothesis, you have this, and for the alternative hypothesis, you have this, okay? So how do we test this hypothesis? Well, let me go to a note and then explain this. So let me explain about testing hypothesis, right? Suppose we have 3 groups. So we have a hypothesis like this. And alternative hypothesis looks like this. At least 2 of these 3 means differ, right? This is the typical hypothesis for the ANOVA, right? So the first question is it possible to test this hypothesis by using pairwise comparison? For example, you can have and you have and the last one now. So suppose you create 3 hypotheses, right? Like this, and this one is called a pairwise comparison, right? So you are comparing 2 means, right? Suppose you accept null hypothesis, right? Now from this, can we say mu1, mu2, mu3? Is it possible? Remember that this is not the mathematics, right? In mathematics, if you have A is equal to B and B is equal to C, then from this you can say that A is equal to C, right? But in statistics, you cannot say this. Why is that? Because there is always a sampling error, right? Remember that? So we cannot use this type of a pairwise comparison for testing, these hypotheses, right? So instead of this, what we do in ANOVA, mu1 is equal to mu2 is equal to mu3. Suppose this is true. That means what? All the data are coming from one population, right? So suppose you have a groups of data here, right? 3 groups of data. And this one is mu1 and mu2 and mu3, right? The means for each group. Suppose mu1 is equal to mu2 is equal to mu3. Then you can say that these data come from one population, right? So the basic principle for testing hypothesis in ANOVA is to test whether data comes from one population, right? So how do we test? In this case, we use a variance instead of a means. When you compare means, right, then you compare, sample means, right? But in ANOVA, in order to know whether data are coming from one population, you need to use variance instead of means, right? So basically, there are two ways to compute the variance, right? Suppose, data are coming from one population, right? And then you can compute variance in two ways. One is called within variance. Within variance. And the other one is called between variance. Now, suppose you have, 3 data sets, okay? And remember that the gasoline type case, so you compute, sample means. So you have, this one is B and this is one C, right? And you compute sample standard deviation. Right? Now, suppose, these data are coming from one population, right? One big population. Now, how do we compute the variance for that population? Now, one way is, right, just take average of, these sample variances, right? So you take right? This is 1A. And the other way to compute the variance is to use, this one. Remember that the variance of x bar is sigma square of n, right? From this, right, sigma square is simply n times x bar, right? So this n is the sample size, right? And this one is computed like this. So suppose you take the so you take the average of sample means, So let's denote it as x double bar, right? And then you compute the variance for x bars, right? So you take the and this one divide by 3 minus 1, right? So this one is the variance for the x bars, right? And then you multiply this one by sample size, right? In case of gasoline types, the sample size was 5, right? So you multiply this one by 5, right? Now, so you compare these two variances. So within variance between variance, actually you are computing the ratio, right? This is called F, right? F statistic. Suppose that this one is close to 1, right? Then we can say that these data are coming from one population, okay? That means what? There is no difference among the sample means, right? And if this one is big, right? Big means numerator is bigger than denominator, right? So that means there is a difference among the sample means, right? Difference among sample means. That's the basic idea here, right? In ANOVA. Right? Now let's talk about F distribution. Right? So remember that the ratio between variance and within variance is called F, right? F test statistic. If you have ratio of variance, right? Variance of variance. This is F distributed. Okay. Graph of F looks like this, right? So it's it looks like a whale, right? And remember that the F is always positive because it's a ratio of variance, right? Variance is always positive, right? That's why we have always positive values for F, right? And remember that if F is very big, right? Big F means between variance is greater than within variance, right? So that means there is difference among sample means, right? So that means you reject null hypothesis, right? Big F you reject null hypothesis, right? So that means the rejection region for the ANOVA is always located at the right end of the graph, right? So this is the rejection region, right? This is decided by alpha value, right? So in case of ANOVA, the rejection region is always located at the right end of the curve, right? So big F means, rejecting null hypothesis, right? That's the basic idea of testing hypothesis in ANOVA, right? Now, so, how big depends on the size of alpha, right? Alpha is obviously, you need to set, right? So usually alpha is 0.05, right? And for the F distribution, right, you need to know two types of degrees of freedom, right? One is for the numerator, and the other one is for the denominator, right? We'll talk about this one when we do the actual example, right? Now, when we do the actual hypothesis testing by using computer package, right? As I said, that the computer gives us the p-value, right? What the computer does is to compute p-value, right? So in order to compute p-value, so you need to know the F test statistic, right? Statistic, right? This one is the between variance and the between variance, right? And once you compute this and you mark here test statistic, right? And the computer computes this area, right? This is p-value, right? So once you get the p-value, you compare p-value with your alpha, right? If this is true, then you reject null hypothesis. So this is true, then you get the you reject null hypothesis, right? Now let's go back to the PowerPoint again. Now we are back to PowerPoint. So we are going to focus on the computer output instead of going through the calculations, right? I talked about already the principle of testing hypothesis, right? And also today I'm going to show you how to use SPSS for testing, ANOVA hypothesis, right? And the computer gives us output like this, okay? And we are going to focus on the interpreting this output instead of going through the complicated equations, right? So basically, this one is called between variance, okay? And this one is within variance, right? And this one is test statistic F, right? This one is computed by this one divided by this, right? So you get this, right? And remember that, I talked about computing p-value, right? So computer computes the area, the right side of, this value, right? So you get p-value here. So this p-value is less than alpha, right? Suppose alpha is 0.05. Then this one is less than 0.05, so you reject the hypothesis, right? This one within variance is computed by taking the variance of the x bars, right? Now I have to talk about the degrees of freedom here, right? And these ones. Okay. Remember that when you compute between variance, right? So you subtract x double bar, right? And then you square this, and you add these things, and right? You square this, and you divide this one by 3 minus 1, right? And this one is the here, the degrees of freedom, right? Why we have 2 here? Let me talk about the concept of degrees of freedom, right? Suppose we have 3 numbers, okay? And the mean is, suppose this one is, mean is 5, okay? Now among these 3 numbers, right? 2 can be decided freely, right? For example, this one is 2 and this one is 7. Now, the last one is automatically decided because this equation should be satisfied, right? So in this case, among 3, 2 can be freely decided, right? So in this case, we say that degrees of freedom is 2, right? So in this case, okay, since even if we have 3 sample means, right? If x double bar is decided, then among these 3 sample means, 2 can be decided freely, right? So that's why we have degrees of freedom of 2, right? And in this case, we have 12. This is because, when you compute the sample variances for each group, right? So for each group, you have to subtract 1 from sample size, right? So we have 5 elements for each group, right? So when you compute the sample variance for each group, you have to subtract 1 from 5, right? So each one has degrees of freedom 4, right? So you have total 12, right? That's why we have 12. And the last one, this is total. Total is just simply the summation of these two, right? I'm going to show you how to get these results by using SPSS, right? Let's go to SPSS. Let me show you how to use SPSS for hypothesis testing. So this is the first screen of SPSS. I already entered some numbers here, right? Now, before we go into the hypothesis testing, let me talk about these 2 buttons at the bottom, right? The first button is for the data screen, and the second button is used to name variables, right? So you click this one, and you can, name variables, right? So first variable is named as mpg, miles per gallon, right? And second variable is named as a gas type, right? So I typed in this ones, right? And if you want to go back to the data, you click this one. So you have, these data, right? In order to do the hypothesis testing, you go to the this menu, analyze, and then for in case of a one-way ANOVA, if you have one kinds of treatment, and then you go to the comparing means here, right? And you have lots of sub-menus here. Among these, you select one-way ANOVA here, right? This is obviously the Korean version of SPSS, right? So you click this one, and you have screen like this, and this is the dependent variable, right? This is the responses, right? So in our case, miles per gallon. So mileage is the responses, right? So you move by using the arrows to the right, right? And then treatment goes to here, right? And factor, right? And so you select the gas type and you move to here, right? Gas type. And then click this one, and then you get the results, right? So this one is the ANOVA table that we talked about, right? Depending on what kinds of software you use, you have slightly different numbers, but it's almost same, right? So this one is the between variance, right? And this one is the within variance, and this one is F statistic, and this one is p-value, right? So this is the how you get the computer output, right? We are back to PowerPoints. Now let's talk about what happens if we reject null hypothesis. In this case, since p-value is less than alpha, right? So we are going to reject null hypothesis. What was null hypothesis? Null hypothesis was mu1, mu2, mu3, right? So rejecting null hypothesis means what? There are some differences among these means, right? So, you want to know which one is different from others, right? So in that case, we need to use a method called two-key, right? Two-key method is different from ordinary pairwise comparison because it considers the sampling error. We said that mu1 is equal to mu2 and mu2 is equal to mu3. From this, mu1 is equal to mu3. Oh, we cannot say this. Why is that? Because of the sampling error, right? So if you use the pairwise comparison, there is always a possibility of making errors here, right? So in order to reduce the problem of sampling error, Tukey developed a method of simultaneous pairwise comparison, right? Simultaneous. So this is the so reduce the effect of sampling error when we do the pairwise comparison, right? There are lots of other methods, right? We usually use a two-key or Bonferroni, right? So how do we do the pairwise comparison? When you do the hypothesis testing by using SPSS, right? You can get the results for the pairwise comparison, right? So let me go back to the SPSS again, right? So we are back to the SPSS, right? So let's go to the analyze again. And you select comparing means, and you select one-way ANOVA, right? So we already moved the dependent variable and the treatment here, right? And so in order to get the pairwise comparison, you go to this button and you select two-key, either two-key or Bonferroni, all right? And then you continue, by clicking this, and you get the results here. You see here? So you see here, you are comparing type 1 and type 2 and type 1 and type 3, right? So if p-value is less than 0.05 and you reject null hypothesis, right? Just like before, right? In this case, what is null hypothesis? In this case, mu1 is equal to mu2 is the hypothesis, right? In this case. And what about this? In this case, p-value is greater than 0.05, right? So you cannot reject null hypothesis, right? So in this case, what is null hypothesis? Null hypothesis is mu1 is equal to mu3, right? Same thing applies to, these things, right? So if you compare mu1, mu2, mu3, right? And obviously you see here, there is a difference between mu1 and mu2, right? Because we are going to reject null hypothesis, right? How about mu1 and mu3? mu1 and mu3, you cannot reject null hypothesis. That means, mu1 is equal to mu3, right? What about mu2 and mu3? In this case, p-value is 0.001, right? This one is obviously, less than 0.05. So you are going to reject null hypothesis, right? So mu2 and mu3 are different, right? So from this, you can get the results of comparing, two means, right? Let's go back to PowerPoint, right? We are back. So from the results of pairwise comparison, right? It turned out that mu1, mu2, right? And mu1, mu3, and mu2, mu3, right? mu2 is different from mu1 and mu3, right? From this, you see, this one has a higher average, right? Second group is different from the other two, right? So that's it. So we are going to stop here for today, and see you next time.